In this video, I want to briefly walk you through the data we're going to collect for our next lab called the ramp lab. For our first investigation, we look specifically at objects that move in a straight line at a constant speed, and we use a toy car to figure that out. In this lab, we're looking at the motion of a spinner moving down a set of pipes that's gradually increasing speed over time. When we looked at the motion of the toy car, we came up with lots of different ways to represent what it was doing. We graphed how the position changes as a function of time. We came up with equations to represent how position changes with time. We just simply described it verbally, saying it moved in a straight line at a constant speed. And we also came up with another representation called a motion map, which represented where it was and the velocity it had at those specific positions. So we had 4 different ways to represent the motion of an object moving at a constant speed in a straight line. For our ramp lab, we're going to look closely at the motion of the spinner going down the rails as it's changing its speed and find out, well, how does its position change as a function of time? How does its velocity specifically change as a function of time? What would a motion map look like for the spinner? And how might we represent either how the position changes with time or velocity changes with time using some kind of an equation or algebraic representation? We're going to start by looking at graphically how position changes and velocity changes over time. To do that, we're going to start by collecting the position of the spinner as it moves down the ramp each and every second. So we're going to collect position and time data, and then we're going to eventually graph that using a software program called Logger Pro to do some further analysis, so then we can then figure out what the velocity is at each specific time. In class, we collected data by marking the position of the spinner each and every second, so we had a table of position and time values. We could then make our quantitatively accurate position versus time graph. You're going to collect data using a video linked in the description below, this one right here, and you can pause the video at specific times to figure out where the front of the spinner actually is. And you do this for each and every second as shown by the timer on the screen here. Once you collect your data, you're going to use a software called Logger Pro to enter your data. Now, you could graph this by hand or enter this in any other graphing software. We're going to use Logger Pro because it's going to make our analysis much easier when we're trying to figure out how fast the spinner is going each and every second. Since this is the first time you're using Logger Pro to graph data, I've got a set of directions that you can use to help you do things like entering and labeling your data, and then changing the graph to properly display your data. There's a lot more steps in these directions here, but you guys can essentially stop after step 3, and then we'll talk about how are we going to further analyze this data together in class. When you get to step 2b in the directions, it talks about labeling your column headings in your graph, and you can do that in a really simple way. You can just take your mouse and double click on the column heading, either X or Y, and a little window will pop up that allows you to name it and say what the units are. And so if you double click on X, we're putting the time values in the X-axis and the position values in the Y-axis. And so if you double click on X, what we want to name it, so the first thing you're going to do is just type out the name, like what's being plotted on the X-axis. In this case, it was time. In this box, it says short MN, that stands for short name. We want to use the symbol or letter which represents what's being plotted, and so we use T as the symbol to represent time. And you want to make sure in the units box you're entering the units of that value, so the units of time would be seconds. When you click done, that's going to automatically label your column heading, and it's going to label your graphs. Remember, our goal is to ultimately find a quantitatively accurate position versus time graph and velocity versus time graph, but right now we're focusing on the position versus time graph, and then we'll use this to figure out how fast it's going at each and every second.